The Federal Aviation Administration's Aviation Safety Program presents the Safer Skies Aviation Training Series. The Safer Skies agenda originated in 1998 when the administrator and her team identified the most critical and most common causes for aviation accidents: aeronautical decision-making, weather, loss of control, controlled flight into terrain, survivability, and runway incursions. Together, these six make up the majority of all general aviation accidents. We encourage all airmen to view all six presentations. The FAA's primary goal is reducing fatal accidents, and that's a responsibility we all share. Let's take the time to focus our attention on these six critical subjects. Hello, my name is Ralph Hood, and I'm the world's luckiest pilot. You know, of all the lies I tell, and I'm an aviation humorist after all, this one actually might be true. I've been so lucky, in fact, that I've ended up on the wall here in the Alabama Aviation Hall of Fame. Come on in and I'll show you. This is my plaque right here, and I'm proud to be on the same wall with legends such as Wernher von Braun, who with his German rocket team in Huntsville, Alabama, helped us get to the moon in the 60s. And also, the Wright brothers plaque is over there. Did you know they started the world's first flight school in Montgomery in 1910? But today I'm here to talk about the FAA's aviation safety initiative called Safer Skies. And today's particular topic is survivability. This means, as you might guess, living to tell about being in an airplane crash. Like most pilots, I am lucky enough to have no first-hand experience in actually crashing an airplane. But I do think I've made some good and some lucky decisions that have short-stopped incidents and accidents before they develop. Modern aircraft, properly maintained, are amazingly reliable. The vast majority of general aviation accidents have nothing to do with mechanical failure. Machines are much more dependable than human beings when it comes to GA safety. That said, mechanical failures do happen, and we as pilots must be prepared for them. The overall goal of the Safer Skies program is to reduce the number of fatal accidents in general aviation. That's a worthwhile and lofty goal when you consider that in a recent 5-year period there were 9,087 general aviation accidents during an estimated 138 million flight hours. That's one accident for every 15,000 flight hours. 19% of those accidents were fatal, resulting in 2,976 deaths. Most of those deaths could have been prevented with better pilot decision-making and survivability techniques. We need to be prepared for all potential failures all the time. But the most critical times are, of course, takeoffs and landings. This is the time of the most radical power changes, the time that we're closest to the ground, the time when we have the least amount of options and the least amount of reaction time. And that takes us back to the root of all aviation safety issues, aeronautical decision-making, or ADM. I think you'll quickly agree that basic ADM issues are at play throughout the entire process of planning and executing a flight. ADM is defined as a systematic approach to the mental process used by pilots to consistently determine the best course of action in response to a given set of circumstances. Another way to look at ADM is controlling the errors. Error management relies upon situation awareness, problem or threat recognition, and good judgment in resolving the threat or the error. A simple way to apply the decision-making process is the 3 P's: perceive, process, perform. Take in all of the available information. Figure out what to do with that information and then do it. After the perform step, evaluate the outcome of your actions, which starts the 3P process all over again. Perceive, process, perform. That's a good formula to remember that applies to all situations encountered in the course of a flight, from tie down to tie down, including an emergency landing. So let's get started on our survivability presentation with Mr. Diego Alfonso. Diego is a Gold Seal flight instructor, FAA designated pilot examiner, and past Flight Instructor of the Year.
Hi, I'm Diego Alfonso, and in my 27 years of flight instruction, you can bet I've seen a few incidents of impending loss of control in an aircraft. And as an FAA flight examiner for 14 years, I like to think I prevented a few in the process. There is plenty of published information out there about the number of general aviation accidents, and there is more than enough information about aviation fatalities in general aviation. What we can only guess at are the numbers of fatalities that didn't have to happen even though there was an accident. What's even harder to nail down is the number of accidents that were avoided because the pilots made all the right moves at the right time. One of the facts that we do know is the number of people who survived the forced landing. In a recent 5-year analysis, there were, as Ralph mentioned, 9,087 general aviation accidents and 2,976 deaths. The pessimist perspective is that's a fatality rate of 32%. I prefer to look at it as a survival rate of 68%. The actual rate is better than 68% because many of the accident aircraft had more than one soul on board. Realistically, a high percentage of the 6,111 plus success stories were simply related to the circumstances, not to the pilot's abilities. Many of the accidents occur in a very survivable situation and environment, like loss of directional control during a crosswind landing. What we're interested in here is the group that survived because of their preparation, judgment, and airmanship when faced with an emergency, pocket factor control. So we're going to break this discussion into 3 parts. First, preparing not to crash. Second, handling the emergency landing. And third, surviving after the dust settles. Part 1 is nothing but a recap of all you've ever learned about managing the risks of aviation, and can be summed up in 3 words: knowledge, training, and discipline. In testament to the successful design, engineering, and manufacturing of the general aviation fleet, only 14% of all general aviation accidents relate to a mechanical or structural failure. The rest are on us, the pilots, with an occasional ATC error tossed in for the balance. And that 14% will be considerably lower if the pilots did a better job of pre-flighting in the first place. What's the old saying? Kick the tires and light the fires? We're not going to spend our time here beating a pre-flight checklist into anybody, but I'm going to spend some energy emphasizing how important a good, thorough aircraft pre-flight is. Your aircraft's POH has a checklist, and you can order a laminated copy for almost any general aviation aircraft on the market. There have been many good articles on pre-flight, but one of the best I've ever seen is by Peter A. Bedell in the May 2000 AOPA Pilot Magazine. Enough said. So we've got the airplane on the right track. Now, what about the pilot? This is a much more complex problem, and every book, video, pamphlet, and seminar in the world will not totally resolve this issue, but there is a very basic guideline that will at least ask a pilot to consider the issues before launching. And it is the PAVE checklist from the FAA and the Flight Safety Foundation. That covers the basics for preparing not to crash. But here's just a few tips that will increase your survivability in the case of a mechanical failure or a power plant failure from any cause, pilot or other. ASCAP is a musicians and performers guild we've all heard of. It's also a pretty useful mnemonic that could save your life. First, know your aircraft. What is your best glide speed, or L/D? What altitude do you need to safety make a return to the departure runway in the event of a total power loss? Is your airplane equipped with an auto gear function? And if so, have you overridden it so it won't add drag when you need it the least? What altitude do you need to make a normal pattern with no power? Second, know the surrounding terrain. If you can't make the airport, do you have a plan for your off-airport arrival? Based upon wind direction and obstacles, which way would you turn to your intended field? Consider that the safest landing may be in the water, even if you can reach land. Next, crew and passengers preparedness. If there is more than one pilot aboard, whose airplane is it in the emergency? A couple of 100 feet up with oil on the windshield, it's no time and place for discussion. Is one pilot going to fly and the other handle radios and systems? Gear up or down? Passengers and baggage secured? These are just a few of the considerations, and all of these issues should be addressed on the ground before the takeoff begins.
So if we have a absolute emergency, I'm going to hang on to the airplane unless you command me that it will become your control.
Exactly.
Okay.
You're pilot in command until I call my airplane.
Okay.
Once I say I have the controls, I have the controls.
We're going to assume for the time being that you as the pilot have made every preparation for every eventuality. And the engine quits anyway. You've prepared for this eventuality for your entire flying experience. And here you are. So now what? Whether you're in a single or a multi-engine aircraft, loss of power does not necessarily spell disaster. We'll never know the number of successful landings after engine failures, because if there is no accident, there is no report. The reality is that if you lose an engine in a single, you're going to come down considerably sooner than you will have planned. If you're in a twin, the length of your remaining flight will depend a lot on the conditions, aircraft loading and performance, density, altitude, and pilot proficiency. Every takeoff results in a landing. Some are just more successful than others. There are fewer accidents referenced to engine loss in twins than singles. But if an accident does occur, the fatality rate in singles is 1 for every 10 accidents. But in twins, it's 1 for every 2 accidents. A couple of factors are working here. The single engine pilot's mindset is that when he loses an engine, he's looking to land. The twin engine pilot's mindset is that when he loses an engine, he's looking to fly. In a twin, even if the performance is designed in, there is a critical phase where the ability to continue flight, much less climb, is very iffy and dependent upon many factors, the most important being pilot proficiency and judgment or lack thereof. Multi-engine power loss procedures and power loss cause and effects are subjects way too complex to tackle here today. But suffice it to say that airspeed, directional control, and zero side slip are the keys to flying away on one. An asymmetrical thrust twin has two critical airspeeds that cannot be fudged. VYSE, best single engine climb speed, and VMC, minimum single engine control speed. Below VYSE, some fully loaded airplanes simply will not climb in standard conditions, even with a test pilot flying. Below VMC, the control surfaces cannot compensate for the roll and yaw tendencies of the other engine still developing full power. If you cannot maintain VYSE, start looking for a place to land before the terrain rises up to greet you. If you allow the airspeed to decrease to VMC, your only option is to reduce the power on the good engine and look for the best landing options. So we're at the point of this discussion that has exhausted all our options for continued flight. In other words, we're running out of altitude, airspeed, and ideas all at the same time. And we're going to make an unscheduled landing. Twin or single, it doesn't matter. There is one very simple and very basic rule which you must never violate. Under all circumstances, fly the airplane. Let me say one more time. Fly the airplane. There are three classifications of emergency landings: precautionary landings, forced landings, and ditchings. We'll come back to these in depth in a couple minutes. In all three classifications of emergency landings, though varying slightly by category, there are three basic psychological factors affecting the success or failure of the survivability of the event. Failure to accept the facts, fear of damaging the aircraft, and fear of personal or personnel injury. The first, failure to accept the facts, in some extreme cases could lead to total non-action until the only option left is a reaction. The FAA says that the time between the occurrence of an emergency situation and the pilot's response to that situation is 4 seconds. Then the pilot goes through the thought process of denying the reality of the situation. All the time this is going on, the options are narrowing. Oil on the windscreen or a hole in the cowling made by a rapidly departing piston is difficult to deny. But too many emergencies come on more gradually. The second psychological factor helping kill pilots in an emergency is fear of damaging the airplane. Now, I love airplanes as much as anyone. They've been part of my life for 43 years. I appreciate them. I take care of them. I talk to them and even hug them when no one is watching. But anytime I'm faced with a decision of protecting the sheet metal or the soles, you better believe I'm going to use every tool and technique I know of to protect my passengers and myself. There is not an airplane out there that's worth dying for. The third factor is fear of personal and personnel injury. This, of course, is a reasonable fear, but it still clouds the decision-making process and can lead us down the path to bad judgment. Naturally, it's easy to stand here and talk about being cool-headed when, for whatever reason, the airplane just won't fly anymore. But cool-headed, rational thinking is exactly what's called for when the options get thin. It's tough to make a good landing when your eyes are closed. Let's back up for a moment to look at the three classifications of forced landings. The first is the precautionary landing. In this case, you're not dealing with an absolute and current emergency. You're trying to avoid one while you've got some options. It might be a rough running engine or low fuel or rapidly deteriorating weather or any number of causes. But you've decided to terminate the flight sooner rather than later. Continuing the flight is possible, just not advisable. The first step is to communicate your situation either on 121.5 or to the controller you're currently in contact with. Mayday and 7700 on the transponder will get immediate attention. Since you've still got power to control your descent, you should be able to pick a pretty good spot. The natural tendency is to find a landing site that causes the least amount of damage and inconvenience. But that nice looking paved road next to the farmhouse may have power lines or phone lines that will make it a less desirable option than the field away from the road. You cannot see the lines from the air, but you can see the poles. If you can, make a low pass and look for all the danger signs. If it's a field, land aligned with the plow lines or the crop lines. If there is a slope, land towards the slope. And allow a little more airspeed at flare to compensate for the slope. If there is a choice of trees or shrubs at the run-out end, choose the shrubs to slow you down. To quote Mr. Mick Wilson from his book, How to Crash an Airplane and Survive, the greater the amount of crushable structure between the occupants and the aircraft point of impact, the lower the transmitted crash forces and the higher the crash survivability. I know of a pilot who successfully stopped an Aerostar on a tennis court by using the wind fence and the net as speed arresters. Since you've got some time to prepare, secure the baggage and use pillows or jackets to protect crew and passengers. Crack the doors. A crumpled airframe will likely render the doors inoperable. Think about the landing gear. A soft field may trip the plane on landing, so a gear up arrival will probably be the best choice. Just before touchdown, cut off or have your co-pilot cut off the fuel supply and the master switch to lessen the chance of fire. And as soon as the plane settles, get all crew and passengers out and away immediately. I used to tell my co-pilots, the captain is the last person to exit the aircraft in an emergency. So if you see me running past you, consider yourself upgraded to captain. Whether it is a precautionary off-airport landing, a true forced landing, or a water ditching, one rule that always applies in all situations is to maintain your airspeed above stall. An extra few knots of airspeed is much more desirable than an out-of-control contact with ground or water. The seats and the restraint system are designed to work their very best at force dissipation when the force is straightforward. Additionally, the aircraft itself will offer much more energy absorption and dissipation traveling forward in a straight line. Definitely arrive at the landing site flying the airplane, but do not carry any more speed than absolutely necessary. There is a pretty simple physics equation that explains the increased risk of higher speeds. KE equals half mv squared. Kinetic energy equals 1/2 mass times velocity squared. In simple terms, that means an impact at 85 miles an hour is twice as forceful as an impact at 60 miles an hour. Doubling the ground speed quadruples the force of impact. In a forced landing situation, you will have fewer options and things will happen a lot faster. This is where the prep we spoke of earlier will pay off. All the short final checklist we just talked about still applies. But as opposed to a precautionary landing where you get to pick your landing spot, now you've got to take the best you can get. And sometimes the best you can get is not so good. Logic says the slowest ground speed, therefore into the wind, puts you in the best position for survival. But that's not always true. Terrain and topography need to be considered on land, and waves need to be considered on water. This is when you've really got to keep a cool head and use all the resources available. For example, if your best option is a logging road through the woods, put the nose of the airplane on the road and let the wings take the initial force of impact. If you have to put it directly into the trees without the benefit of a road, try to contact the trees symmetrically so the plane does not slew to one side. The only way you're going to have the control needed to pick your spot is with enough airspeed to keep the airplane flying. Before impact, you want to secure loose items, position protective padding, crack the doors, configure the landing gear, shut off the fuel, kill the master switch. All the same things you'll do in a precautionary landing. First, though, is always fly the airplane. Second thought is protect the occupants. Use the mass of the aircraft to absorb as much of the energy as possible. Airplanes are replaceable. People are not. We're going to cover personal locator beacons a little later. But if you don't have one of those, it's a good idea to know where the ELT is located, so if you decide to leave the airplane, you can take it along so the searchers will find you and not the empty airplane. Now let's talk about water ditchings. The general pre-impact checklist still covers the basics, but if you're in a water environment, your survival gear will be a little different. We live in Florida, and the natural getaway trip for a Florida pilot is the Bahamas. There may be 700 islands in the Bahamas, but there is a whole lot more water than land, and much of it very remote. But no matter where you live, if water is below you for any longer than your glide time to land, you should be fully prepared for a ditching. And as I mentioned earlier, seeking water like a mountain lake instead of rough terrain could put you in a ditching environment 1,000 miles from the nearest ocean. Assuming you've got the airplane under control, and assuming you have exhausted the quick fixes to get the immediate problem solved, pick your landing area and direction, then communicate your position. Where to land? Obviously, if there is either land or a boat nearby, head in that direction. But which way is the wind blowing? And what about the waves? Your instincts tell you to land into the wind for the lowest possible ground speed. But if the waves are an issue, that might be a bad choice. Anything over a light chop, say 2-foot waves, and you'll be better off landing parallel to the waves, hopefully in the trough. And what about the landing gear? Boy, ask 10 different pilots and you're going to get 20 different answers. For my money, I've got a retractable gear aircraft. I'm probably going to keep the gear tucked, on land or water. Most fixed gear GA airplanes landing in the water with the gear down will rock forward on the nose, but not flip upside down. This pipe cup that went in on a photo mission is pretty typical of what to expect. A low-wing airplane will be more at risk for catching one wing first than a high wing, particularly if your landing attempt is between parallel waves in a trough. About the only time I put the gear down for a forced landing on terra firma is if the landing site was clearly hard-packed and relatively smooth, like a dry pasture or a road. Flap configuration is another topic of discussion, but underwater in a low-wing aircraft, I will choose to leave them retracted and let the belly of the airplane slide on like a seaplane. In a high wing, I will use less than full flaps for a flatter approach. Keep in mind, though, that in certain airplanes, a Cessna 206, for example, lower flaps will impede the opening of the rear door. Fire, of course, is less of an issue on impact with the water. So I will probably maintain any power I may still have all the way to the water, like a soft field landing, not cutting the fuel supply. The obvious exception is in-flight fire, which we'll get to in a minute. If you are smart enough or quick enough to have your inflatable on before the crash, don't inflate it until you're clear of the aircraft. If it is in your hand as you egress, remember that it's a lot easier to don when it's uninflated than when it's inflated. It's amazing how disorienting being upside down in the water in an aircraft can be. Most planes will float for several minutes while all the void spaces fill with water. So you will have a little time to react, but if the plane is upside down, your head is in the part that will fill first. Keep calm, that's easy for me to say, and get yourself oriented before you release your seatbelts. Know where the exit is and where the handle is to release the door or window. Never let go with both hands after unlatching until you are clear of the aircraft. Once you do, you have lost reference to where you are. If you're confused about which way is up, remember that bubbles always rise. Darkness, of course, makes this process even more disorienting. So make absolutely sure you know which way is up before releasing. Clear the aircraft, protecting your head from the wing structure. Remember, the wing is up if you're upside down in a low wing. Another topic with some pretty strong viewpoints for discussion is the ballistic parachute recovery system found in the Cirrus, and lately a few other aircraft. This technology has been around the ultralight industry for many, many years and has saved hundreds of lives. The use of an aircraft parachute for ditching is a controversial subject. When an aircraft under parachute contacts the land, the gear and the fuselage, maybe even the wings, absorb much of the energy as they contact. However, when that same aircraft contacts the water surface, it will generally hit pretty flat and solid, such that there is nothing much to crush. Almost all the energy is transmitted to the seats, which of course are designed to withstand great G-forces, but not necessarily those forces under those conditions. The parachute is a great idea, but I will think twice about deploying it in a ditching situation where a highly survivable conventional ditching may be a better bet. You'll find some links for more info at the end of the presentation. There are several very good survival courses that teach safe egress from a ditch aircraft. If you spend any time at all exposed to the risk, get thee to a survival course. We'll list several of them at the end of the presentation. Right now, let's talk just a little bit about in-flight fire. Fire in flight can originate from several sources. So first, identify the source before taking any action. A plane will continue to fly with the electrical master switch off. So anything that smells electrical, kill the master switch, along with the alternator and battery switches if they're separate. and then start the identification process. Turning everything off. Then turning the master back on and switching electronics back on one at a time, slowly, until the problem is identified. In the meantime, head for the nearest practical landing site. Check breakers for one that might be popped or hot. If it's popped out, do not push it back in. If the fire is identifiable as an engine or fuel system issue, maybe even a gasoline heater in a twin, the first step is to cut the appropriate fuel selector to off, retard the throttle, lean the mixture to idle cutoff, and proceed immediately with all the forced landing procedures we've already discussed. Turn off any heater or defroster controls to keep heat and smoke on the forward side of the firewall. I cannot stress enough the importance of immediate and decisive action. Seconds can make the difference between life and death. I'd like to introduce you to Mr. Doug Ritter of Phoenix, Arizona. Through his organization, Equipped to Survive, and as an aviation journalist, Doug has researched and designed many tools and techniques for survival. A full survival course is days, even weeks. We got about 15 minutes. So Doug is going to review the essential survival gear we should all have with us. He'll also share some basic survival information that we both hope you'll never have to use.
Thanks, Diego. Now that you have survived the crash, it does not mean that your ordeal is over. The fundamentals of survival could make the difference between life and death. Survival requires three things: knowledge, tools, and luck. We can't help much with the luck, but we can help you with the knowledge and tools that you'll need to survive. Improvisation is fundamental to survival. Tools make it a lot easier to improvise. So the focus of our discussion will be on tools. Before we get into the tool section, however, I'd like to discuss an acronym that I like to use, and that is STOP. The first letter of the acronym is S for stop. Take a deep breath, sit down if you're able to, calm yourself. Whatever got you into this circumstance, into this survival situation, is over and done with. There's nothing you can do about it now. Your job now is to survive. To survive, the first thing you need to do is think. The second letter of the acronym is T for think. Think things before you do them. There are often no second chances in a survival circumstance. You need to make sure that the choices you make are the right choices. You can't go down to the Walmart and replace resources that you've used up. The third letter of the acronym O is for observe. Take a look around you. See what resources you have available, what's in the plane, what nature provides, what other passengers may have on them. The fourth letter of the acronym is plan. Develop a plan. Prioritize your needs, develop the plan, stick to the plan. Don't change the plan unless the circumstances change. The first thing we're going to focus on is personal survival equipment. If it isn't with you, it can't save you. You need to carry the personal essential equipment on your person at all times. The other rule that we like to remember is that 2 is 1, 1 is none. Redundancy is very useful in a survival situation. You want to carry 2 of the most essential items of survival. Your most fundamental survival tool is your brain. It's a really good idea to bring it along for the ride. Besides your brain, there are a few other fundamental survival tools that you want on your person at all times. You want a knife that you can bet your life on. You want some means to start a fire. You want something that you can use for shelter, and you want some water. You may ask why I haven't included food in this list. The reason is food just isn't that important. It takes up a lot of space, it weighs a lot, and most of us are running around with quite a reserve of food on our own person already. A few of you may need to carry a few other pieces of very important survival gear on your person at all times. What we're talking about is personal medications, where you should always carry a 3-day supply, and glasses. If you cannot function without your eyeglasses, or if you wear contacts, you should always have a spare set of glasses with you. I'd like to encourage you to dress for success. What I mean by that are two things. One is to be sure you're wearing natural fibers or fire-resistant fibers. Your clothing should not be made out of things like nylon or rayon or any of the other ons that will melt in a fire. The other thing is to make sure you dress for the environment you're going to be flying over, not necessarily just the environment you've left or the environment you're flying to. It's 110 degrees out on the ramp here in Phoenix today. People are going to look a little askance at me when I walk across the ramp carrying a heavy flight jacket. But all I need to do is fly 100 miles north and it'll be 30-some degrees tonight. That jacket will come in mighty handy if I need it. After your brain, your number 2 fundamental survival tool is your knife. There's an old saw that the best survival knife is the one that you have with you. If this is the best knife you have with you, that'll have to do, but we can do a lot better than that. But you also don't want to have a knife that's inappropriate for survival. If it's a knife that you've seen in an adventure movie like Rambo, it's probably not a knife you want with you. A knife like this that's so big may be very useful hacking your way through the jungle, but it's impractical for other uses. Unless you're flying over the jungle, you probably don't want a knife this large. You want to avoid knives with very sharp points because this point can break. You don't want a knife with no lock on a folding knife because it can cut you. Bad thing to happen in a survival situation. What are we looking for in a survival knife? We're looking for something practical, utilitarian, something you can bet your life on. Something like this will do very nicely. Doesn't have to be that big either. Something smaller, such as this, will do just as well in almost any situation. Or a folding knife. A small folder, 3 inches long, is great. The folder I carry, one hand opening, very utilitarian blade. One hand opening is very important because you may not have both hands available to you. And the blade should always lock so it can't injure you inadvertently. What about Swiss Army knives? There's nothing wrong with a Swiss Army knife except that most of them will not lock the blade in place. But there are some that will. Wenger makes Swiss Army knives with locking blades. And both Victorinox and Wenger make larger Swiss Army knives with locking blades. Then there's multi-tools. I always have a multi-tool with me. It serves 2 functions. It provides you the redundancy of a second blade, and it provides you an excellent set of pliers, which also can come in very handy making use of what the plane provides you for resources. Fire has been part of man's survival since prehistoric times. Fire is not only useful for the heat it provides, but it makes a great rescue signal and can be a significant boost to morale. So let's take a look at what makes a good fire starter. Your most basic fire starter is a match. You can waterproof them using fingernail polish or wax. The next step up is something that's waterproof and windproof. These are available in a number of sizes and will burn under any circumstances, so they're much more reliable. Next we have lighters. Lighters are quick and easy. A lot of people have one on themselves anyway. The only problem with lighters is they occasionally run out of gas. You can also get more sophisticated lighters that are both windproof and waterproof and run out of gas. Flint and steel is probably the most reliable fire starter you can have. They're available in many sizes. These modern flints are made of artificial ingredients and are much easier to create a spark than an old-fashioned flint and steel. And they create lots of sparks. The only problem with a traditional flint and steel is it requires 2 hands. If you're injured, it's very difficult to make a fire that way. So I prefer one-handed fire starters. These don't create quite as big a spark, but you can use them one-handed. And if you've got good tinder, you don't need a big spark to make a fire. You should always carry a small amount of tinder on you because it's probably the most difficult thing to find in the wild. This can be commercial tinder like this, or it can be as simple as cotton balls and Vaseline that you make yourself. Surviving is nice, getting rescued is even better. The most basic way to summon help is to use a signal mirror. The most basic signal mirror has no aiming aid and requires 2 hands to use no matter what. A true signal mirror has a hole in the middle through which you will aim it. The best signal mirrors have aiming devices in that hole that make it even easier to aim one-handed. Glass is the most reflective material. It makes a great signal mirror, except it's heavy, and if you drop it, it breaks. So I recommend a good plastic signal mirror. These are available 2x3 and 3x4, pocket size, inexpensive, works anytime the sun is out, and is visible for 20 or 30 miles in the right circumstances. Even the hologram on a credit card has been successfully used to summon help. A signal mirror is a lot better and more reliable. Another basic survival signaling device is the whistle. They're low cost, they don't use batteries, and they're much more effective than yelling. For nighttime signaling, you can use a flashlight or even the little pocket LED light that you may be carrying. Strobes can be used, or the latest technological advance, the laser flare, which can be seen for miles and miles and miles. Speaking of technology, your cell phone could save your life. The difficulty is they're not that reliable, they run on rechargeable batteries, and so you don't want to bet your life on your cell phone working. Plus, there are a lot of areas in the United States that still have no cell coverage. Many pilots carry a satellite phone. These work great in remote areas, but there are also many areas where you can't get good satellite coverage and you won't get good communications. The ultimate survival signaling device is the 406 megahertz personal locator beacon. This is similar to the ELT in your aircraft, but can be carried on your person. These transmit a signal up to satellites and are used to summon search and rescue. Because they're coded individually, they know who's in trouble and where to come get you. Another advantage of PLBs is they have lithium batteries that last 5 to 10 years. The survival shelter you carry on your person needs to be lightweight and compact. There's always the ubiquitous space blanket, but for me, I just as soon use a couple good garbage bags. These are inexpensive, lightweight, multi-purpose, and bright colors can also be used for signaling. You can survive weeks without food, but only days or even less without water. The amount of water you can carry on your person is limited. Try to carry a flask of water or some of these prepackaged pouches. But I also always carry a gallon of water per person, at least, in the back. This can just be bottled water. Even if you fly over lakes and streams, you still need to carry water. Just because there's water down there doesn't mean you'll be able to get to it after the crash. It's always a good idea to carry a complete survival kit in the plane. This is mine. The difficulty is it may not get out of the plane with you. So again, if it isn't with you, it can't save you. I designed this pocket survival pack so that it would be light, fit in your pocket. You can build one yourself, you can buy a commercial variety, but it's an excellent way to make sure you have the important gear you need on your person. It's all in here except for the knife. Or you can carry a little more in a pouch that fits on your belt. Either way, it's with you when you leave the aircraft. Another way to ensure your survival gear goes out the plane with you is to wear a survival vest. This can be built up using a military surplus vest, or there are new vests on the market, some of which are available with flotation. Speaking of flotation, let's talk a little bit about life vests. If you're flying over water, a life vest is your essential survival gear. Your typical surplus airline vest, or even a new airline vest, is probably not the best choice. It's not designed to wear all the time. It's easily punctured. It's really a one-time use device. Much better are life vests that are designed to be worn and donned quickly, or constant wear vests. This is a pouch style vest. You put it on your waist. It's available to quickly don over your head if necessary. Great for passengers, okay for a pilot. For pilots, I like to see them wearing a constant wear vest. This is a yoke style. Fits over your head. You wear it all the time. If you need it, it's there. You don't have to don it. The other piece of overwater survival equipment you may want to invest in is a life raft, especially if you're flying great distances over the water. This is a complicated subject we won't get into right now, but there are a range of styles, a range of prices, and a range of quality. So do your research before you purchase one. We've covered the survival fundamentals here. The next step is up to you. If you don't assemble your own survival gear, it can't save you. There's a list of resources at the end of this program that will help you do just that. Strong people don't necessarily survive. Smart people do. Be smart. Be prepared. Be equipped to survive.
Obviously, the very best survival tool you can carry is Doug Ritter. If that's not convenient, at least carry some of the great equipment he's researched for us, because every single flight is a potential forced landing. Most of the potential emergencies can be avoided before they ever become issues with good pre-flight planning and assuring that your aircraft is in acceptable mechanical condition with enough fuel on board. Even then, you should start every flight with an expectation of an engine failure and a plan for handling that failure. When I give a multi-engine check ride, you can expect that somewhere in that flight I'm going to pull an engine. The candidate specs it, and 99% of the time the candidate handles it very well. Most engine failures will happen on takeoff or go around, which of course are the worst times for such an event. When you think about returning to the airport, consider that unless there are two parallel runways, your turn is more than 180 degrees. You've got to turn more like 225 degrees to get back on the runway center line, and then 45 degrees back the other way to line back up. That will have to be more like 180 degrees plus 90 degrees. If you were very close to a short runway when you initiated the turn back. And that turn should be made into the wind, keeping the plane closer to the intended landing point. Seaplanes on a large lake have a distinct advantage here because they're not restricted to the confines of a single runway. Another debatable technique is how steeply to turn back. Common sense says a gentle, no more than 30-degree bank turn will lose less altitude in the turn. But considering that a 180-degree turn at a 30-degree bank and 75 knots indicator airspeed results in a turn rate of 8.4 degrees per second. That 180-degree turn will take 22 seconds and lose 292 feet altitude. Considering that the steeper the turn, the higher the stall speed, you don't want to take this theory too far. But for my money, I will trade altitude for a quicker turn, particularly if the maneuver was happening very close to the field. A 45-degree bank at the same 75 knots indicator airspeed results in a turn rate of 14.5 degrees per second. So the 180-degree turn will only take 13 seconds. Total altitude lost, 207 feet. In most airplanes, once I've hit the altitude that I know I can return from, I will pitch for best glide speed attitude and immediately crank in 45 degrees of bank in the direction I have already determined is best for my conditions. Keep in mind, though, that the natural tendency is to pull back on the stick as the houses get bigger. And proper engine out techniques demand that you maintain the proper pitch attitude to achieve the best glide airspeed. I cannot emphasize this enough. Engine out, push forward. This technique has to be practiced until mastered. This is not on-the-job training. This is where preparedness pays off. At a familiar field, you should have a plan in place for every takeoff. Whenever you land at a new field, take a few seconds to survey the surrounding areas, anticipating the course of action if your engine fails in the subsequent takeoff. Things tend to happen fast in an emergency, and the fewer decisions you have to make, the better off you are. There are a lot of things to consider, and many of the right decisions can be spring-loaded in your mind. It's critical to know your airplane's capabilities and limitations. What is the best glide speed? At what gross weights? Do you have enough altitude to make the nearest field? Is the craft heavily loaded? And is the density altitude above standard? Probably. Are you as sharp as the test pilot that set the standards in a brand new airplane under controlled conditions? Probably not. When was the last time you practiced engine out procedures in a twin? Or performed a full power off approach and landing in any aircraft? How different is it with gear up versus gear down? What difference does the propeller pitch make? You'll find those last two make a huge difference, so don't forget them. Pilots of twins use an accelerate stop or an accelerate go calculation to determine their balance field lengths for takeoff. In twins, the formula is a moving target because there are different requirements for Part 91, Part 135, and Part 121 operations, and even different requirements between different manufacturers and different models. But the critical numbers all twins can look at are some combination of accelerate stop decision speed, accelerate go decision speed, rotation speed, takeoff decision speed, takeoff safety speed, best single engine angle of climb speed, and best single engine rate of climb speed. This is a little bit of generalization, but for point of discussion, here you can think of VR and V1 as synonymous, and VYSE and V2 as synonymous. In a single, it's simply a distance calculated from the POH or flight manual. The difference in thinking is that if you lose an engine in a twin, you have an option of continuing the flight. So you have to make a decision. In a single, no matter where you lose the engine, the decision to land is made for you. These runway lengths are in the POH or flight manual. Just don't forget to add a little for field conditions, aircraft condition and weight, and pilot proficiency. There are other factors involved in the decision to continue, like cleaning the airplane procedures, height needed to clear obstacles at the end of the runway, and a few others. But we're not offering a twin rating in all makes and models here today. Speaking of leaving the end of the runway, when you're planning your touchdown point in an emergency, consider that it's far better to roll into the woods at the far end of the landing area than to fly into them at the near end. Remember, it's not about protecting the airplane. It's about protecting the people. There's an old adage in aviation that's worth remembering. There are three things you can't ever use in an airplane: fuel left on the ramp, the runway behind you, and the sky above you. An intersection takeoff at a 10,000-foot runway is one thing. At a 3,200-foot strip, it's another. Every power plant failure does not have to result in a crash. Forced landing? Sure, if you lose power to all your engines. But there are untold numbers of power loss in one engine of a twin that are total non-events, not including the pilot's heart attack when he gets the rebuild estimate. Every single flight in a glider or a airplane results in a power-off landing. And what about the space shuttle? Though it has a glide ratio similar to a dictionary, every single landing has been successful. Why? Because the pilots are working within their expectations and their capabilities. They are properly trained to treat their engine out arrival as a routine part of the flight. What's more, every crash does not have to result in serious injury or death. Once you're in a situation that a forced landing is imminent, the holy trinity of aviation, aviate, navigate, communicate, will save your skin. First, fly the airplane and honor the airspeeds. Every airplane has a best glide speed at a particular weight. Know it, and when you need it, peg it immediately. Second, plan your next move and put the plan in action. That would involve decisions and actions about where to go and how to configure the airplane. Third, make everyone aware of exactly what's going on. Crew, passengers, controllers. From here, your experience, your training, and your skill take over. The good news stories all come back to a skilled and cool-headed pilot who does all the right things at just the right times. Yes, and throw a little bit of luck in there too. But remember this, general aviation has a perfect record. Every flight we launched has returned to Earth. We haven't left one up there yet. How each flight returns to Earth is the primary concern of the Safer Skies program. It's our goal to match the number of successful takeoffs with an equal number of successful landings. If we can't get all the airplanes back in one piece, we at least want to get all the people back.
When we take the time to analyze all of the factors involved in safely completing even a simple flight for a short distance, we begin to realize the responsibilities that we carry as pilots in command are not to be taken for granted. This Curtiss pusher behind me has quite a few original 1912 parts, and this airplane was donated by my good friend Mr. George Epps. George had a forced landing in this very airplane right near his own grass strip here in Alabama. George survived the crash, but then his problem was getting out of the woods with a broken foot. The goal should be 0 mistakes, 0 errors. Realistically, that's not possible, but when the technical skills under your control are in hand and you've minimized the errors, the potential threats are greatly diminished. But at every stage of flight, there are continuing situations that require your recognition, perceive, your decisions, process, and your actions, perform. Early in-flight recognition of a mechanical problem, making a decision about how to deal with the problem, and then putting the impaired aircraft on the ground or in the water with the least possible force and damage might not get you home for supper, but it should get you home. The 3 P's of perceive, process, perform should be constant and automatic whenever you're operating in any flight crew capacity, in the air or on the ground. Being prepared for you and your passengers to survive an emergency landing is just one more step in our continuing quest for safer skies.